Good morning, good day, and good evening. Welcome back to Tech of a Tea. I am, as always, your host, Brody Robertson, and today, I believe, is episode 146. Yes, and today we have a returning guest. Last time she was on with Luna the Fox Girl, but I decided to do this time separate episodes so we can go more deep into their individual topics. Welcome back to the show, Asahi Lina. How's it going?
Hello, it's doing pretty good.
For anyone who doesn't know, like, what you do, I'm sure most people have probably heard of you in the FOSS space at this point, at least to a little bit, or at least heard of the project you're working on. Give a brief overview of sort of what you do.
So I've been working on the Asahi Linux project, which is a project to bring Linux to M1 Max and the Apple Silicon family. And so I started working on the GPU kernel driver after Alyssa had been working on the GPU user space driver because GPU drivers have two parts. So we had a user space driver in the works, but there was nothing for the kernel. So I started working on that this year, and that's what I've been doing pretty much this whole time.
And the last time you were on, it was definitely not in the state that it's in now. Like, we'll talk about this just before, but you were just getting, like, so you had a Python user space driver, is that correct?
Yeah, so that was a Python user space driver that does what a kernel driver would do as an experiment to because we have to reverse engineer the GPU because we don't know how it works. So
Because Apple won't help you.
yeah, so as part of that, initially to get a feel for how everything works, first we use a hypervisor to like snoop on what macOS does with the GPU, and that's all based on Python stuff. And so then I use the same code but sort of backwards as a demo to sort of prove the concept that it could work. And so this is basically a Python code doing what a kernel driver would do in user space on a development machine that is not the M1, but is connected to the M1 via USB. So it was this crazy thing where like all the video frames and all the geometry and all the GPU stuff was happening over USB.
So it's basically kind of the worst case scenario for getting anything working well, but enough to at least work out if it can be done in the first place.
Yeah, the idea is that like to get the design of the kernel driver right, I need to understand how the GPU works to a certain point, and it's much easier to iterate in Python on a host machine, where I can just run a script and keep rebooting the M1 or whatever, and I can have like an interactive shell to debug things and pretty color printing of everything and all that stuff. So it's a lot more convenient to initially figure out how it works in Python and then build this proof of concept. And then once you have a proof of concept that is like, okay, I can actually run some real apps with this, and it renders multiple frames and it basically works and it's doing what it's supposed to do. And you figure things out like how to allocate and free memory properly, and how to get like the notifications that a frame has finished rendering, and like what the concurrency issues are, and how can you do multiple things at once. Like I can answer all these questions with experiments in Python, and part of it was running real apps, part of it was actually just like dumping single frames from an app and rendering them manually in Python, but then I can do more complicated things like doing multiple things in parallel. And so by doing all these experiments, I can figure out how it works and figure out a design that makes sense. And then after that is when I started on the kernel driver.
So, what would you? So the earliest thing that was like basically rendering something, like when you would consider it doing at least that basic of rendering a single frame, was that like the triangle? Or was there something a little bit earlier than that?
That was the triangle in Python, yeah. So that was the triangle that was, it wasn't running a real app, it was a frame, as in the geometry and the commands dumped from the triangle running on macOS, as the macOS Mesa driver would send to the macOS kernel driver, taking that data and putting it in Python and doing what the kernel driver would do in a Python script and getting the GPU to render a triangle. That was the very first thing that worked.
That was what? So last time we recorded, it was 5 months ago, and you were a bit further ahead at that point. So somewhere between 5 to 6 months ago, you would say you was sort of in that state.
Yeah, something like that. That was, I think it was 5 to 6 months ago. Yeah.
Because when you were last, because I know you definitely had a Nuchi 2D work, like, okay, I wouldn't say working well, but functioning to some extent, because you had the I think one of the thumbnails I used the glitchy render that you worked
Right,
out how to
right.
force. But things have come along a long way since then. I've got I think a video coming out tomorrow doing sort of an update on where things are at right now. But where are you at right now? Because if someone hasn't heard, considering like the jump that there's been, I think they might be a little bit impressed where it's at now.
So we have a real driver now. And it's not like, a full driver that can run the latest Falcon OpenGL everything, fancy pants. But it's a real driver that can run OpenGL ES2 and ES3. And Mesa is also improved to pretty much that point. So like ES3 is not 100% yet, but it's getting there. And basically, we can run desktops, we can run games, we've been playing Zoonotic and Quake and Super Duck Kart um, on like accelerated Wayland or Xorg desktops with KDE and GNOME.
Mhm.
And yeah, it all works. I think Alyssa was working on getting Firefox Web Render to go smoothly. I think it's already there with OpenGL ES3. So yeah, it's getting to the point where this is something you want to use as a desktop driver for GPU acceleration.
Is there a release out of Asahi Linux that has this ready, or is that still sort of in the works?
So we want to release before the end of the year because we think it's pretty much there. So right now we're kind of just tying up loose ends, and yeah, hopefully it'll be out soon.
I honestly think it's really impressive how far along this has come along. Like, as I've said multiple times, I have no idea what's going on with reverse engineering a GPU driver. Right, like writing a GPU driver with documentation, I wouldn't have any idea what I'm doing. I'm sure many other people are sort of in this state as well. Seeing how far it's come along, going from, you have the hardware here, the hardware has no documentation, to getting where you're at now. I think anyone who's seen that has to be at least a little bit impressed. I don't know what sort of feedback you've had about it. Like, yeah, what is the feedback you've sort of received about where everything's at right now?
I don't know. I mean, a lot of people are saying that it works. Just the other day, I got someone saying that it works better than macOS for one game, which is pretty hilarious. To be clear, that's not the case for most workloads right now
Mm-mm.
for a bunch of reasons. Like there's some stuff that is like 10 times slower than on macOS. We still don't know why. But there's a lot of low-hanging fruit for performance to be figured out. So right now, benchmarks don't really mean anything other than it's getting better. But yeah, I mean, like if you just run a desktop, it's just smooth. It feels like macOS,
Mm-mm.
and that's really really cool.
Yeah, I've seen
Yeah.
the GL Mark II benchmark you posted, where I think it puts it in line with like an RX 550, something like that, which I'm sure you can get more out of that chip, but just the fact that it's where it's at now, I think is just really cool.
Yeah, like it's kind of funny because like I always get people talking about benchmarks and like is it faster on macOS? How much is it on macOS? I was like, okay, like
Yeah.
that stuff doesn't really matter right now.
Mm-hmm.
But what matters is that like we're improving all of these things about the whole stack, right?
Yeah.
So the fact is like right now it's at a point where it completely changes the desktop experience versus not having a driver because not having a driver it's actually surprisingly smooth with the CPU, but as soon as you do something like use the full screen window on one of the machines with the higher resolution screens, it's really obvious
Yeah.
that it's dropping frames. And then with the GPU, it's just like, no, you can do 4K at 60. It just works. It's just smooth. And that makes a huge difference. And also tear-free video and all that.
Well, one thing I did want to ask about was specifically Wayland, because I know you've said that X11 can be done, but the focus has clearly been on getting the Wayland version of GNOME, the Wayland version of KDE, things like that working. Why is Wayland? I know there's definitely this idea that X11 is like, this giant spaghetti code base, but from your perspective of working with getting these desktops working with the drivers, why is it the Wayland is the focus right now?
So X11 does work, by the way.
Mhm.
Like right now, you can run an X11 desktop, and it works fine. You get tearing, which is expected with the mod setting driver right now, but that has nothing to do with with our part. There's a patch set for the mod setting driver. There's a PR that was just opened to add tear free to it.
Mhm.
So that's it's kind of a hack for Xorg, but it makes it tear-free with some limitations.
Mhm.
So this is less about the GPU and more about how Wayland and Xorg handle the entire concept of getting frames from apps into a composited desktop
Mhm.
out into a display. Not so much a GPU, but the display device itself.
Yep.
Um, because Xorg is basically this ancient, it's based on this ancient model where, you have a frame buffer and the display is just scanning out of the frame buffer
Mhm.
and you draw into the frame buffer directly, right? And that's why you get tearing. Or you like try to copy a frame buffer in just in time when the frame is changing so it doesn't tear. But like there's always this race, right? And you're trying to track the frame as it changes on the display device. So your XOR expects to know, like get an interrupt on every frame, like a
Mhm.
60 FPS or something like that. So the M1 display controller doesn't have that. The M1 display controller is based on a model where you give it a frame
Mhm.
and it will switch to that frame instantly on the next frame on the display
Mhm.
and tell you that it finished. And so um, that's exactly the model that Wayland uses. And it's the model that macOS uses. And macOS kind of pioneered this. And Wayland was kind of I don't know if it was explicitly the response to that, but it was definitely the answer to the, okay, Xorg's model doesn't really fit how we want to do composited desktops these days, where like the
Yep.
idea is that every frame should be perfect, right?
Mhm. Mhm.
Um, so yeah, like Wayland naturally maps and works perfectly on the display controller on M1 devices. XR by default doesn't even use the page flipping, so it just writes to the frame buffer, you get tearing. With the tear-free option, it does use that, but there's still one option that VSync, as in the frame limit, doesn't work because there's no wait for the next frame
Mm.
operation on the display controller. Oh, you only get that when you actually change the display, but Xorg kind of wants that separately. So if
Mhm.
you run like a game VSynced on Xorg, even though it won't tear, it also won't limit the FPS to the proper display FPS.
Okay.
So VSync basically doesn't work on Xorg right now,
Right. Right.
and I'm not sure if we can fix that. It's kind of an imitation of how the whole stack works. So Wayland doesn't have any issues like that.
Mhm. Well, I'm not too surprised that the things have changed with the way that graphics and display tech is handled, considering that X11 was, I think the spec was originally defined in 82, 72, it, like, a very long
Yeah,
time ago. I can't remember the exact year. I've done a full video on X11 nonsense, but a very long time ago. I'm not surprised that things have changed a little bit since then.
yeah. It's I mean, we've it feels like we've added a lot of patches on top,
Hmm.
and like workarounds and bypasses for the old stuff to make things like full screen games work properly.
Hmm.
But at the end of the day, like the model is you still have the old stuff under the hood, right? So you can't get rid of it,
Hmm.
and that's kind of the problem that Xorg has, right? That you can't really, um, get rid of the craft. It's always going to be there.
Yep. Yep.
So Wayland just says takes that, puts it in a box, calls it X Wayland, and say, okay, here's your Xorg. And by the way, VSync works fine on X Wayland because that's presenting through Wayland, so that's no problem.
Yep. Yep.
Yeah. So
I was gonna say something that completely slipped my mind. Um, well, actually, Wayland. I know there's a lot of people that will definitely complain about sort of the state that the general Wayland experience kind of is right now, because there are things that are not supported in the Wayland desktop available right now that have been available in X11 for a long time, and it doesn't surprise me that there is this sort of, I guess, pushback against the use of Wayland on like a general experience, but from what I've seen, it's definitely getting a lot better now. For most people, most of the time, Wayland's in basically a good enough state that you could reasonably use it. Now, when, Fedora and stuff swap a couple of years, like way too long ago, that's another story entirely. But I think right now, especially with the recent changes where you don't necessarily have to have something be frame perfect, where there's the new protocol to do that, and then the new protocol to handle fractional scaling, like passing fractional scaling data properly. I wouldn't be surprised within like a couple of years if Wayland is basically at the state where, I don't know, a good like 99% of people on Linux are perfectly happy using it. There's always going to be those edge cases because, it's not a one-to-one drop-in for what X11 is. But, yeah, I don't know where I was going with this. I'm just talking about Wayland now. I tend to do this. Yeah, I don't know where I was going with that, actually. Yeah, unless you have something to add to that, you will just move to somewhere else where...
I think Wayland and X are right now kind of at that point where they both have a similar amount of problems.
Yeah.
So it's actually reasonable for most people to try out both and see what they like.
Mm-hmm.
I think at the beginning of the year, we were still seeing some issues with Wayland, like the fractional scaling stuff. I remember I tried it on Asahi Linux, and the first thing I did is open up Firefox, and it was blurry, and I was like, wait. So that was like X Wayland on KDE, and it was trying to do
yeah,
yeah. So KDE fixed that with one stuff, and then with like asking X to do native fractional rendering, and now we have the native Wayland rendering, which I think KDE and Qt have always supported anyway, but like in their own way, because Qt always had fractional rendering.
I believe so, yes.
But probably not standardized in a way that would work with other compositors or something like that.
Yeah. Well, there was no general standardized protocol yet for it, so KDE was sort of like doing their own thing. And then there's GNOME where it's
I know fractional scaling worked, but like it was not. Yeah, there was something around there. Yeah.
Yeah. Then there's GNOME where it's like we could implement fractional scaling, but then there's GTK which doesn't support it in the first place. So, I know that a couple of people very involved in the GTK project have said it's probably not going to support fractional scaling until GTK 5. So, it's going to be a while. And then you've got to wait a couple of years after that for the desktop to actually be in GTK 5. Yeah.
The funny thing is that Apple just cheats and doesn't do any of this.
Yeah, how does Apple handle it?
They only do 1x and 2x. And then they do full screen. Like at the display controller level, they just do virtual resolutions that are not the real physical resolution, and then just scale. And that's it. So you render your desktop at a different resolution than your physical resolution to handle, fractional scaling. And, you use more GPU power and it looks a little bit softer, but macOS had always had this sort of, we don't do font hinting. We do smooth vector graphics, so we don't care about pixel perfect. Like their entire UI is designed not to expect pixel perfect graphics. So it's always been kind of smooth anti-aliasing stuff that it doesn't really matter if you scale it. And I guess they just have a good scaling algorithm, the display controller, and they just go with that.
Well, Apple also has sort of the same advantage that Android has, where a lot of stuff is just built in the one toolkit. So, obviously there is the Electron stuff, but...
Android actually does fractional, though. Android does actually do, like, full, like, configurable font size, DPI, all that.
But what I mean is you don't have, 10 different toolkits doing all of their own different things. Well, you can have that on macOS, but most of this problem falls apart when you give people choice. But a lot of stuff is built with the main toolkit that is expected. When you go with that, there's a lot more. You have a lot more control over what is done.
Yep.
That's why if you stay.
That's always how it goes, right?
Like if you stay just in KDE, everything that's going to be using the KDE scaling is going to, work nicely. Yep. The second you step outside of that...
For the most part.
Yeah, okay.
I found a really funny race condition. I don't know whose fault this is or if it's supposed to work in some other way, but when I start KDE, sometimes at 1.5 scaling, sometimes the taskbar is blurry. And apparently what happens is that it applies the fractional scaling while it's starting up. And so if Plasma starts before that setting gets changed, it starts at the wrong scaling. And because it doesn't support changing scaling for existing apps on the fly, what KDE seems to do on Wayland is that they just scale the output so you get blurry surfaces until you restart the app, which is better than nothing. So I agree with that. I think that's a good idea. But then you better set the fractional scaling globally before starting Plasma. So something is backwards in the startup sequence there. So yeah, those kinds of things obviously need to be fixed.
Well, no software is going to be perfect. Definitely not.
But
it's could be worse. There could just be no fractional scaling in the toolkit, like GTK. From I've heard multiple people tell me that it wouldn't be that bad to refactor it. Then I've heard other people saying that it would be an absolute nightmare. I have no idea who's actually telling the truth. All I know is it's probably not going to happen. So, I don't know.
Fractional scaling is pretty hard for things that assume integer pixels. Because like there's especially I don't know if even websites have this issue. Like I use 1.5x and sometimes I scroll Twitter and the DM window starts scrolling on its own. And I am convinced that's a fractional scaling issue where they like set the position of the window and the scroll and then read it back and set it again and do the rounding issues. It just crawls. It's so annoying. So you get things like that, right? Like where like you're rounding down to pixels and back and converting, and that just makes everything such a pain.
Yeah. Well, one of the main focuses people talk about with fractional scaling is like blurriness, but yeah, it doesn't surprise me that there are other things that are a mess. Like blurriness is sort of the least of your issues because a lot of the elements that you do have aren't that big of a deal. Like text scales properly. Any UI elements you have that are drawn in code, so like your buttons that you'll probably draw in code, that will scale fine. It's sort of only the rasterized images that are a problem. But I'm not surprised that other issues tend to crop up when you don't fully test your fractional scaling implementation.
Yeah, I think the sort of code issues like that are kind of the worst part because the UI elements, I mean, if you have 2x elements and you scale them down to 1.5, it's fine. I mean, that looks fine. It's only people who are like, I must have exactly square pixels and like, all my designs must be super sharp and mapped one-to-one to my display. And
Yeah.
you know what? That stops mattering with high DPI displays because we can't see the pixels anymore. So that only really matters for low DPI, and we're kind of moving away from that.
Yeah,
but
sorry,
yeah.
go on.
No, yeah, but yeah, it's more about like retrofitting fractional scaling into a system that doesn't already natively base itself on floating point coordinates and things like that. Can get really messy.
Yeah, it doesn't surprise me that it's a mess. One thing you made sort of you mentioned, I think you did a couple of streams on it, was moving up to another version of OpenGL. So you're working on your OpenGL 3 stuff. For anyone who has, and me as well, who has no idea like why going up to a new version of OpenGL matters, what's the big deal with that?
It's just more features. So applications, for example, Firefox will not enable web render on OpenGL 2, so it will work, but it'll use software rendering for the actual website. Though you do get WebGL. But so it's things like that, right? So the apps can require certain versions or have more features in certain versions. Super Card has, I think, 3 or 4 renderers depending on which version you have, and like as you go up, it gets fancier and the graphics get fancier.
Yep.
So it's things like that, right?
And where are you at with the OpenGL 3 right now? Is it because last time I saw you post about it was like 90% test coverage or something?
So I think OpenGL ES3, which is different from OpenGL 3, is at like 96, 97% or something like that. And I think most of what was missing was, I think as I said, it was transform feedback and some issues with multi-sampling and stuff like that.
Yep.
But we have most of it. So for example, we have multiple render targets, which are required for the modern versions of Energy2D to work properly. So that's good. And yeah, a lot of apps are really starting to come together on OpenGL ES3. That's different to OpenGL 3. And also OpenGL 2, which we also don't fully support yet. And that's just about like really old, clunky legacy GL features. Because like OpenGL ES is like the cleaned up version of OpenGL.
Right.
And then OpenGL is like Xorg. Right? It's like so old. And it has all kinds of crazy things that make no sense on modern GPUs. But you have to emulate them anyway. And the thing is, there are no official OpenGL 2 or 3 conformance tests.
Right.
There are only official OpenGL ES2 and 3 conformance tests, and then there's like an OpenGL 4 conformance test, like 4 point something. So we can't do that yet. So we've been focusing on ES2 and 3 because that's both the most important part, and that's what we have tests for. But there is a separate OpenGL test called Piglet. And so Alyssa has been fixing stuff there, and I reviewed some of the merge requests to fix that. And it's really just random stuff. It's like telling Mesa to emulate some things that should be emulated and fixing minor bugs in places and just a lot of very random things. And then I think there's a couple more major things that actually need development for OpenGL.
Mhm.
But it's mostly, yeah, just a lot of really old crafty features that we need to either support or just decide nobody cares about and just not support, which we're also doing because there's literally stuff in there that's just like, why would anyone ever do this, right?
Mhm.
So there's at least one code path in Mesa that just has a warning message printed that is like, the app is doing this thing. We don't think anyone cares about this thing. It might render wrong because there's no point, right? Like in spending time on stuff unless we find an app that actually cares about that. So OpenGL has
Right.
a lot of that, right? So we're not trying to do 100% OpenGL compliance because it's a waste of time. It
Right.
makes more sense to work on newer versions and implement the stuff that apps actually use. And so that's why the ES conformance tests are more important initially. Um, and honestly, by the time we get to OpenGL 4, that might be the time to switch to Vulkan with Zinc on top.
Mhm.
So we'll see how that goes. But right now, what's useful to people is OpenGL ES2 and 3, and the OpenGL parts that work easily on top of that. And so that's what we're doing.
Well, yeah, I'm sure if later down the line you're like, hey, you know what? We actually do want 100% compliance. Why not? We're bored. That can come later if you really wanted to. It's sort of, I would imagine it's a lot more important just to make sure that things that matter, like are working, and then anything else, like optimization, for example, like this is a whole different thing, but optimization can be dealt with later. As long as things are working, you can deal with the rest of it at some point else.
Yeah, the thing is, like, there isn't even like 100% OpenGL compliance. Like, as far as I understand it, basically NVIDIA is sort of the standard for how OpenGL works because it's so complicated and it has so much craft that there's actually no consistent specification that tells you how all of those crazy features interact.
Yeah.
So, you have all these separate things, and then if you combine enough of them, the spec doesn't actually tell you what's supposed to happen. So, there is no 100% OpenGL compliance other than copying what NVIDIA does.
Right.
But it doesn't really matter because unless an app is actually doing any of this, nobody cares.
Yeah. Yeah.
So what matters is supporting OpenGL ES and getting compliance there because that's a good test suite and it's stuff that people actually use. And then making sure that the things up people actually do on OpenGL 2 and 3 actually work. And then focusing like it's more important to focus on adding new GL extensions and incrementing the version support to add things that people actually use in newer versions, as opposed to like handling all this legacy stuff that nobody uses, right?
Yep. Yep. One thing you mentioned in there was the Vulkan drivers. That's not something that's a thing right now, but what is that zinc thing you mentioned? I've heard other people mention zinc in the context of Vulkan. I've never bothered to like probably look into it though.
So Zinc is just OpenGL on Vulkan.
Mm-hmm.
So it's a translation layer, just like all the other Vulkan on metal type stuff that there is.
Right.
But it's built into Mesa, and so the idea is that when you get to that level of underlying feature support, um, there is one implementation of OpenGL that handles all this craziness once, and then if you have a Vulkan driver for your GPU, you can just run it on that and not have to worry about all the corner cases. So that's the idea there, and it
Right.
supports like modern OpenGL 4 or something like that. Um, so when we have a Vulkan driver that can handle that, then it might make sense to effectively deprecate the current OpenGL 2.3 driver and just switch to wholesale to Zinc on Vulkan. And that was still use, by the way, the at least the shader compiler that Alyssa wrote, and also all the knowledge we've gotten writing the OpenGL driver. But it's entirely possible that in the future, what we're doing now will be deprecated. But the whole point of this is, the learning experience of understanding how the hardware works and how to implement all these things correctly on the hardware.
Yeah.
And also the shader stuff, which is going to be shared anyway, which is a big part of it.
Mhm.
So, like, it's not wasted work. A lot of people ask that. It's like, why are you doing OpenGL? We can just do Vulkan and then do OpenGL on top with Zinc. Well, because doing Vulkan to the point where Zinc is going to work is going to take a much longer time than OpenGL, and it's a lot less incremental than OpenGL.
Right.
So it makes a lot more sense to figure all this out with OpenGL and go, step by step. And then in the end, if we have to throw it all away, that's fine because we already we got there, through a path that makes sense and that we could follow to get to that destination. While if you say make a Vulcan driver now, from the beginning, it's like what where do you even start, right? Like
Mhm.
it's too much stuff has to work at the same time for Vulcan to work.
Right, you wouldn't build a bullet train before building a steam train. You want to have that like
Yeah,
fundamental of this. We understand how a train's supposed to function. Then we can build the more complex stuff on
yeah,
top of that.
exactly.
Yep, yep.
And since Vulcan is going to take longer, this means that like today, hopefully this month we can release something, sorry, that people can actually use and get it, an accelerated desktop.
Mhm,
And so
mhm,
that's really important, right? And so yeah, that's the answer to why not Vulcan. But Ella is working on a Vulcan driver.
mhm.
Um, and that runs. That's already. She's working on Mesa, so it's on the same code base as what we're working on. And I have plans for the kernel side to support all the features that Vulkan needs eventually. And so the idea is that my kernel driver is not going to be upstreamed until we've settled on an interface that should support all the future Vulkan features. So that's one reason that people ask me is like, when is your driver going to be upstreamed? Linux has a policy that the interface between user space and kernel space can never be broken
Mhm.
in terms of backwards compatibility. And so that makes it very hard to fix that graphics driver design.
Mhm.
Um, but making the good design from the get-go is also hard. So that's also a different road that I'm walking, right? So the UAP that I have now started off as a prototype, and I've been cleaning it up into something good enough to ship to people. And it has a version check, so if you run a driver that is mismatched with the kernel, it'll just fail. Same as like with NVIDIA and stuff like that,
Yep.
which is not upstreamable, but is what we want for development because it means we can fix things, right?
Mhm, mhm.
Um, so whenever this gets released, we would have to tell people make sure you upgrade all our packages at the same time because if you upgrade Mesa and don't upgrade the kernel, it's going to stop working. And also when you upgrade, probably new apps will stop launching until you reboot. That's just how it is. Like that's part of being on the bleeding edge of non-upstream kernel driver.
Yep.
But this time I have a version check, so it's not gonna like corrupt or something. It'll just stop working.
Yep.
But like that's the state. That's the work in progress state, right? And then I'm going to be modifying that UAPI to support the
Uh,
features that Vulkan
what is
needs,
a
like
UAPI?
yeah, UAPI. It's the API between the user space and the kernel
Ah,
space.
yep. Okay. Because you
So
were
I'm gonna
just throwing that term out there without saying what the U was.
sorry. So yeah, it's called the UAPI, and so that has to be stable when it's upstream. So I'm going to be working on improving that to add things like multiple command queues and things like there's a thing called sync objects, which is where you can set certain things to be dependencies for certain other things. So you can queue work on the GPU and say, when, but even across devices, you can say, okay, when a frame comes in from a webcam, then run the GPU render job that'll render this Discord window, which will then enable the compositor to render the whole desktop, which will then enable the display controller to present the frame. And in theory, if all this magically worked as it was supposed to, you could have the CPU asleep the whole time.
Mhm.
Um, in practice, that doesn't work unless you have like a lot of very overcomplicated hardware support for all these things.
Yep.
But at least you can have the user space apps asleep and have the kernel do all this chaining and dependency management. And so that's the idea that the UAPI is going to support these sync objects they're called that let you chain things like that and have dependencies. And the kernel will manage, triggering the GPU driver when the webcam driver has a frame and that kind of thing. And so that has to be added for Vulkan because Vulkan needs these for, the. It also exposes this for the user to use, like in games, like render this, and once both of those internal frames are ready, then combine them with a post processor shader, all that kind of stuff. And the game still these days needs all the same stuff.
Mhm.
And also compute is another thing we're going to have to add, both because a lot of people want it and because we're going to need compute to emulate some GL features that the hardware doesn't support.
Mhm.
Um, and then another cool thing is that I don't know if you heard about this. Carl has been working on Rusticle. It's already released in Mesa.
Yes. Yeah.
Yeah, the Rust new OpenCL stack in Mesa. So that should
Very
also pretty
excited for
much
that.
yeah, that should also pretty much just work on our driver once we have the basic compute support because it's all based on the same shared shader infrastructure that Mesa already uses. So I'm also really looking forward to that. And yeah, that also needs UAPI changes to support creating compute command queues in the kernel and submitting jobs and all that. And then also memory management. The Vulkan needs more advanced memory management, which is going to need a bigger revamp of the, how the kernel does all of that.
Mhm.
So it's all these changes that we're planning because we need them for future stuff like Vulkan. And they don't necessarily have to wait for the Vulkan driver to be to that point, but I do want to at least have the drivers, using the features so we can prove that they work.
Yep.
And yeah, so that's all the work that's going to be happening before upstreaming, because that started the process that we have to follow.
Yep. Well, you sort of gave like 1,000 different directions to go there.
Sorry.
No, it's fine. The more that you talk, the less that I have to talk. Um, so you've said a lot in there about Vulkan drivers one day, Vulkan drivers eventually. If you probably don't want to even remotely give a time frame because then someone's going to hold you to that. If you had to imagine, let's imagine a theoretical where you can actually work this out. If you had to imagine when Vulkan drivers could possibly be a thing, how long do you see that being out for the project?
I have no idea how to answer that question. But what I will say is that my hope is that by around the middle of next year, we have at least enough of a proof of concept to prove that these UAPI features work
Mm-hmm.
and function properly. So not necessarily a Vulkan driver that supports anywhere near compliance, but at least that can run demos that use these features
Mm-hmm.
and prove that all of this works as intended so that we can stabilize the UAPI and submit it upstream.
Yep.
That's my hope. I have no idea if it's going to happen. I think it's plausible though. Just need to work together to make sure, like with Ella, to make sure that we get this all this backend stuff hooked up. And yeah, I mean, she's already running VK cubes. I mean, Vulkan, it's at the cube stage at least, so it's not like there's no Vulkan driver.
Oh, right, of course. Yeah.
Yeah, I mean, we have the cube in Vulkan, so it's not zero. But obviously, there's a lot of work to be done to support all the fancy stuff.
Yeah.
So I hope we can at least have the proof of concept level for the UAPI features by around the middle of next year, just so that it doesn't block starting to upstream the driver.
Mm-hmm. Mm-hmm.
But yeah, as far as like Vulkan that you would actually use with games and with Zinc and all that, and they would work at least as well as the current OpenGL does, I really have no idea how to answer that question. It could be sooner, it could be later. It also depends on on how much time people have to work on it and all that. And the thing about this kind of project is that it depends a lot on people like volunteering their time
Yeah.
and you know people becoming interested. Like Ella just showed up and started working on Vulkan, right?
Mhm.
It's not like we asked her. So things like that. So I can't answer that question unfortunately, but that's kind of my hope.
What, you mean your games are more complex than a blank cube in an empty space? One thing I did want to ask you about, because you get a lot of attention, being a VTuber doing all this, doing your, 10, 12-hour streams. Obviously you get a lot of attention, but you mentioned there is a lot of other people involved in doing this as well. Obviously there is also Alyssa, and Alyssa does get a lot of attention for a lot of the other stuff that she's involved with, but who else do you think sort of deserves more attention for what they're doing that no one really hears that much about?
I think there's a lot of people in the Asahi team that like others don't hear much about. Like Jan Cornell took Alyssa's DCP driver, which is the display controller driver, which has nothing to do with the GPU. And that's what we need. Like that's required for the GPU to actually run a desktop. So we can't run a desktop with the dumb display driver we've been using until now.
Mhm.
So Jan has been working on that. I helped out a little bit recently, mostly by deleting code. And so it had emulation for this VSync stuff for Xorg, and it was broken and was actually breaking it, and I took it off and it fixed it, but then there's no VSync, which is, I think, what you're actually supposed to do. Yeah, there's, he's been working on that. Sven's been working on USB 3, on a lot of other random stuff. Also DisplayPort output, which is not shipping yet, but it's in the works. And then it says that Ella's working on Vulkan, and she almost never gets mentioned, but that's going to be a very big thing
Mhm.
pretty soon. And there's, of course, there's Markin that kind of, keeps everyone together.
Mhm.
And then, who else?
I'm sure you just
There's
keep going all day with this. I just
sorry,
like
yeah, I mean there's like
no, no.
Chadnet's working on the speakers with Povik doing the whole audio system stuff. And then someone what was the name? There's someone doing I think it was Alan or something like that, working on the neural engine, which is really surprising because I didn't know if anyone was gonna sign up for that. No one in the main team kind of had an interest in that, and then someone just showed up. It's like, I'm gonna figure out the neural engine, which is really cool. Also, apparently it can be used for image processing too. So I wonder if there's more than just sort of neural network things that it can do. So that can be kind of fun. And yeah, it's the thing is, anyone is like welcome to say, I want to do this, right? And so there's a whole team of people like that. It's just that everyone wants to hear about the GPU drive.
Well, yeah, the point I was getting at was the work that you're doing is like, it's impressive to see. It's easy for someone who has no idea what goes into this project to see. Hey, look, KDE works now. Hey, look, I can play Xenodic at ultra settings. Hey, look, I don't know. Let's say one day you have OpenCL working, and then I don't know, some compute stuff's happening. What you're doing looks really impressive, but there are less visually impressive things that are going into this project as well that are just as important to getting a good experience with this hardware.
Yeah, like someone recently like submitted the keyboard backlight driver, and it's like one of the simplest drivers, right?
Mhm.
It's also their first time reverse engineering that kind of stuff and writing a
I
driver
honestly
for
had
it.
no idea the current Macs had backlights. It's been that long since I've used a MacBook.
So many people were asking for that, right? And you think it's just the keyboard backlight, yeah, but people really appreciate like having a keyboard lit up in the dark, right?
Yep.
It's even stuff like that.
Yeah, that's totally fair. So one thing I wanted to ask is sort of, I don't know how much attention you pay about this, but what sort of reaction have you gotten from doing this work while being a VTuber? Because there is a lot of people I've certainly noticed, at least in my comment section, who have no understanding at all what this is. Someone asked me if Luna was an AI the other day. So yeah.
Yes.
What sort of reaction have you gotten from? From generally. Obviously, your streams are very positive. Like, I'm sure you've had the occasional troll shot from time to time, but just how's that sort of gone for you?
So the actual streams, I actually don't really get that many trolls.
Mhm.
Like at the beginning, I got a few. I don't think I've had to ban more than like 4 people or something like that.
Wow.
Not counting the porn bots,
Oh
which
yeah,
are
you get
like
those
interesting.
every
Yeah,
day. Yeah.
yeah. I mean that's just YouTube, but yeah. I mean, pretty much. People are very very nice, and I really really appreciate that. And also very helpful, like in my streams, especially when I started working on Rust. Um, I should mention that because like until the Rust part, I was working with things that I was familiar with, Python and C. I'm a Rust newbie, or I was.
And then you became a rush
And
shill.
and like I got so much help from the Rust community, both offline and in the like Zulip, and like directly on my streams from viewers. Developing this whole like object model for the GPU to make it all work reliably and have the memory safety and all that. I had
Mhm.
no idea how to like architect that in Rust. I thought it might be possible, but like I couldn't have done it myself,
Mhm.
not with my Rust knowledge at the time. And so, you know, that was really, really cool.
Mhm.
That I could get all this help from so many people. And even today, people are like, oh, you can do this in Rust. Oh, thank you. Yeah. Um, yeah, as far as the comments, I get a lot of really cool comments directly, like over DMs on Twitter, on my YouTube channel. There's a lot of people that, from the very beginning, send me messages like, you know, thank you so much for doing this. You're an inspiration to me, and you inspired me to go into kernel programming or computer science or something like that. And that just makes me really, really happy. So
Mhm.
I really, really appreciate that kind of stuff, and I'm really happy to be getting those kinds of comments.
Mhm.
And then I guess there's hacker news.
Yeah. Yeah.
um,
Yeah.
so
How can use a fun place?
I think it's kind of interesting that it seems to be very split between people that really don't get it
Mm-hmm.
and people that think it's really cool.
Mm-hmm.
Um, and sort of they always fight it out in the comments every single time. And I don't know. I mean, another thing is that a lot of people seem to confidently answer questions in like wrongly confidently answer things. Um, because the whole VTubing thing is very different for different people.
Mm-hmm.
Like we each have our own reasons to do it, and it's just a form of self-expression. I think one comment I liked is I don't remember if this was Hacker News or Reddit, but someone mentioned that
Just
it
as
isn't
bad as
really
each
any
other.
different.
Hacker News is just orange Reddit.
Depends on which subreddit. The Rust subreddit is usually pretty nice.
Okay, yeah, that's fair.
Um,
Go to r slash
but
Linux though and you change your mind.
But anyway, I think that they said it's like this isn't really any different from someone on a forum with an anime avatar.
Mm-hmm.
It's just the equivalent in 2022, and I think that's a good way to put it, right? That it's just the image you choose to represent yourself online, and the name you choose to represent yourself online,
Mm-hmm.
and the way you choose to express yourself, and the reasons for that is might be different for each person, but this isn't new, right? Like people have been adopting different virtual appearances in different ways since the dawn of the internet, pretty much, at least since we had like images. Um, so a lot of people like seem to have this sort of visceral reaction that this is weird and new, and I think that's a good place to think about it from.
Mm-hmm.
Is just like no, we've had this all the time, since the dawn of of forums and all that stuff in the late 90s and 2000s.
Mm-hmm.
It's just that now it's animated and on YouTube, and we make videos about it, and that's it. It's not that different.
The only difference is that you have like we've got this tech to do, you know, the moving 2D images.
Yeah,
But it'd be no different. Like what you do on your streams would be absolutely no different if you just did the exact same thing without a face cam. Like,
yeah. I mean, the actual work would be the same. I
mm-hmm.
think a lot of people really appreciate the like having the a view of the person doing things,
Mm-hmm.
because it makes it more engaging and friendlier.
Yeah, yeah.
And so I credit a lot of that to all those nice messages I get. So I'm really happy doing this. And I think a lot of people also don't understand like why it makes that kind of difference because they're just like, you could just not show your face.
Mm-hmm.
Yeah, but it's not the same.
There is a lot of there's a we could go into a lot of the research that's been done over the years over why having some sort of avatar, some sort of face cam, something there is just better for making content. Like this is something that is well established at this point. There's no point even having the discussion about whether having just no face cam is better. It's not. Like there's a reason why
Yeah.
there's a reason why every single streamer now has a face cam or does VTubing. It makes for a better content.
Yeah, and it's not just like, because some people think about it from the, oh, you get more engagement and therefore more money or more ad views or whatever, or more, like people are more interested in the stuff I do because I'm
Mhm.
doing it like this, right? It's getting people interested in computer science. It's getting people interested in computer science and in programming and kernel programming that wouldn't otherwise, and that wouldn't have gotten interested if I were just to face the streamer
Yeah.
because it wouldn't have been as engaging, right? So
Mhm.
the engagement stuff isn't just about, the numbers under the video. It's actually getting people interested in the subject. And so that's why I keep doing it, right? Like, I don't actually care about engagement. I don't even know how I ended up with like 17,000 Twitter followers. I
There's
was not expecting
17,000.
that.
Jesus.
I was not expecting that. And like, that's not my goal. But the only thing I can say is that like, as that number goes up, so does the number of people leaving comments like that,
Mhm.
saying that like I helped them, get interested in this kind of stuff.
Mhm.
If that's what this is resulting to, then I'm gonna keep doing it because
Mhm.
that's what I want.
Yeah, just working on reverse engineering GPU drivers is definitely weird enough to get a bit of attention, but it also being done by a cat girl is going to get a bit more attention.
No. Yeah, I mean, the cat ears kind of came later, but
Well, yeah, that's a
um,
new thing. I did notice that you rebranded your Twitter. Actually, wait,
we'll
that
see how
reminds me
long
of a
it stays.
hilarious.
But
Oh, that reminds me of a
Aw.
hilarious thread I
Yeah.
saw on Twitter. Hilarious thread I saw on Twitter. So, I think it was about the recent stuff about like KD running and things like that. Uh, Someone said they're like, "Oh, it's so impressive how much work Asahi Lina has done on this." So no, they said they used the new name you got on Twitter. They said Lina, and someone corrected it under it with like asterisk Lina, and there was like this giant thread just discussing like just the merit of VTubing.
I mean, that's part of the fun, right?
Mm-hmm.
And it's also you know, sort of it helps break this idea that if you are doing this kind of work, you need to do it in a certain way and be a certain kind of person.
Yep.
Because you don't, because that has nothing to do with with the work, right?
Mm-hmm.
So if that's also why I do this, because it's like, well, I'm doing this because I enjoy doing it like this,
Yep.
and if you want to do something like that too, you can do it too, right? I've seen comments like, well, no one's gonna take you seriously, in technical circles if you are a VTuber, um, and doing it this way and whatever. Well, I mean, I gave a presentation at the Xorg Developers Conference, and the people there took me seriously.
Yeah.
And I've been on
Weren't you
video
also
calls with
didn't you,
like Mesa developers.
didn't you have the witch hat on as well during that one? Or was that a different?
That was the first one, yeah. That was the
Oh no.
surprise for the talk. I rigged it the day before. I'm like a members only stream and spent like 9 hours on it or something, including fixing T2 debugs. And yeah, no, that was the sort of I mean, I say joke, but I kept it on the whole month. Because me and Alyssa have the whole kind of sorcery thing, theme going on with this with the GPU reverse engineering. So we just made the talk theme like that, and I got a hat. It's pretty cute.
It's it moved. I actually haven't watched the talk yet. I didn't realize the thing moved.
Oh yeah. I added the physics. Like the ribbon on the side there has like 6 different chained pendulum nodes. It's pretty cool.
I was just
'Cause
paying
I wrote
attention.
I wrote the physics engine for Inner 2D.
Oh, I was just paying attention to the bat. I didn't I didn't notice the ribbon was moving.
Yeah, the bat like jumps around all over the place.
That's awesome. The only reason I asked about the reception you've had, I don't know. Maybe they just like to bother me about whenever I do a video about RC Linux. Maybe they just like to bother me about like who you are, because I'm not going to name the person, but I have had a certain disgruntled GPU developer on a certain project who was really bothered by the fact that you'd done all this work and they couldn't find any sort of discernible previous work that you had done. And they're like, how is this a thing that exists? This person has no history. And somehow trying to use that to discredit the work that you've already got. Like, I don't understand.
I mean, I don't know what to, like. I hadn't done any DPU work before this. It's just kind of picked it up as I went. I mean, Alyssa helped me out a lot. I mean, obviously, like, I mean, I have her on Signal and everything. I mean, we talk a lot. We have calls and stuff. So a lot of people were confused when I started working on this. Or like, what, isn't Alyssa working on that? We're working together on the same stuff. I joked on my like intro stream that like it was all really me and not her. I mean, obviously that was a joke. But we are we've been working together since the beginning. And yeah, like but I mean, as far as like personally, I didn't have any GPU experience before this. I just kind of picked it up as I went. And the thing is, like, it doesn't really matter, right? Like,
Well, yeah, ultimately what really matters is the work that you've got now.
yeah. And I was gonna say something else. Oh yeah, I remember another comment on Reddit. Someone said that I must be like a secret Apple employee working undercover or something like that. It's like, I wish. Yeah, no, the things people come up with are kind of funny sometimes.
Yeah, it's kind of like people just want to know who is behind. They don't just want to accept that. Hey, this is how you're portraying yourself online. They're just obsessed with finding out who is behind the cat girl. We must find out. We cannot just let the work exist as it is. We must find out more.
Yeah, I mean, I don't even know like how to answer that question because like this is who I am. This is how people know me in Mesa and the Kernel in like it's not like I'm putting on a show for YouTube
Yeah,
and
yeah.
and then there's like another secret Mesa developer like like actually doing the work, right? Like I was on a video call with Jason Extra and then the same as I'm doing right now, right? Like this isn't you know it's not acting for YouTube. It's just who I am, right?
If
And
you act for hundreds of hours while developing GPU drivers, that's actually really impressive, and you should probably not be a developer. You should probably just go to acting.
I'm actually terrible at acting. Like that's by the way the cat ears thing was more of like a joke on purpose, and I'm really bad at like consistently like playing that role on my streams.
Yep.
That's how you can know that I'm not an actor, right? Like I'll say the yeah at the end and stuff, and like the first day I kind of got into it, and then like a week later like completely forgot.
I don't think there's any VTuber out there that keeps their character up. Like I don't. Even the ones who are dedicated to their character, eventually it slips you. Know what? This is too hard. I'm just gonna go back to talking normally.
That's the thing, right? I mean, like I'm not. It's not like I'm playing a party or anything. It's just like I'm just doing my development work.
Yeah.
I just chose to do it like this because I enjoy it and because I mean the feedback loop of what I'm getting from people is really positive. And I'm just gonna keep doing it. But yeah, I mean there's no like deception or big secret or whatever. It's just me.
It's just you and the work that you're doing.
Pretty much. And that's the other thing is that people saying like, how is it possible that you do this? Watch my streams, right? Like it's all on there.
Yeah.
You can see how I started from like nothing and got to where I am. I mean, it might take a while to watch them all, but like it is documented.
A while's one way to put it. Wait. If I go to Social Blade, it should tell me how many streams you have, and then I can work out how many hours you've streamed, because it's too many. Actually, one of your streams is more than I stream in a week. Social Blade. Let me see. 58 upload. Oh my god, there's 58 uploads. Let's just say at least 300-400 hours. Just
yeah, probably. might be 500, depending on when I really got into the 10+ hour streams.
Yeah, that like that just the streams alone is kind of crazy to me. Like, how do you like manage your stream? I've not actually sat down and watched entire one of your streams. I know I'm sorry about that, but how do you handle your streams? Like, do you take a break at some point during it? Do you get some food? Are you a crazy person? Do you just go 12 hours straight? How do you do it?
No, so I take brief breaks. I do eat on stream. People seem to enjoy it when I do like eat the invisible food thing, so I do that. I usually have a snack towards the maybe 2/3 portion of the stream, and I have lunch before my stream, so I always start at 3 p.m. And I do have water, of course, and tea and that kind of stuff. And I take very short breaks sometimes, to go to the toilet or just take a very quick walk, or just if I need to like refill my water and all that kind of stuff. But I don't take any long breaks, except that one time there was like the epic cube on Rust on Linux stream, which was like, I think it was like 15 or even 19 hours in the end. And that got broken first when YouTube crashed, because YouTube like streaming crashed that day. And when it crashed, I told people, okay, I'm gonna go to the convenience store, buy dinner, I'm gonna eat dinner and see if it's fixed, and then I'll like redirect or something and continue. And I split the stream up. That was the only time I've taken like a proper dinner break. But that's fine because I have enough snacks to last, and then I usually have a bit more dinner after the stream, and it's fine. So that's usually what I do: is I have lunch before the stream, I have a snack about 2/3 in, and then I have a lighter dinner after the stream, and that's the pattern. And a lot of people ask me, it's like, how can you do this for so long? So streaming actually helps me concentrate somehow.
I've
Um,
heard other people say
and
that as well.
yeah, like because I can't go, goofing off or starting to chat to people or
Yeah.
watching YouTube videos or something like that. But also just the feedback from people in the chat also helps. And depending on how concentrated I am, I'm better or worse at following the chat.
Mhm.
But I've also tried over time to make it more engaging just by talking more about what I'm doing, which um also helps me sometimes.
Mhm.
So like that's not a particularly difficult thing, but it does take some time to get used to doing that.
Mhm.
So that's something that I try to keep to try to keep up more these days. Is just kind of keep people a bit more in the loop because I know it's very hard to follow what I'm doing already if you're not already experienced with this. So anything I can do to help people find it more interesting, I will try. But that's pretty much it. I'm really just working, trying to concentrate on what I do, and trying to talk, my way through it. That's pretty much it.
Yeah, I definitely have a bad habit of goofing off when I'm supposed to be working. Like it takes me a little bit longer to plan out my videos than it probably should. Uh yeah. A couple of YouTube videos here, a couple more YouTube videos, couple more YouTube
Yeah, I'm just
videos.
gonna watch this one and this other one, and oh look, another one popped up in the recommended feed, and maybe I
Yep.
should. Yeah, I know the feeling. Yeah, so streaming helps a lot with that. And like some people ask me, is like, do like part of your work streaming? I stream almost all of my work.
Mhm.
Um, I sometimes do like git management or fixing some particular bug or some random thing off stream. Um, and you can probably find the git commits with the times to tell you that. But most of what I do, almost all the important stuff that I do is on stream.
Mhm.
And part of it is just that is that I concentrate on stream better. There have been at least a few. I think it was like last week on Thursday. Alyssa nerd sniped me with a problem, and I spent like all day on that off stream. So I basically did a stream without streaming. That's
Yep.
rare. I almost never do that. So like people are getting pretty much all my work on the stream, which I think
Mm.
is important because there's no like secret, like I'm really preparing to get this all like because you could do that, right? You could like pre-prep for stream and kind of know ahead of time what you're gonna find and turn it into a show,
Yep.
which might be more engaging and might
Mhm.
get people more interested, but it's also kind of lying, right?
Mhm.
Because then you are presenting that you are doing all this stuff, um, in a short time when you
Mhm.
actually prepared for all of it. I don't
Right,
do
right,
that.
right.
So yeah, but you get like my stream prep is like 15 minutes before I turn on the computer, turning everything on, and if I'm going to be working on a particular thing, I might like clone the Git repo or install the OS. Like for the M2, I was halfway through a last minute reinstall because I kind of messed up and stuff like that. But I'm not actually doing any of the coding or reverse engineering
Mhm.
before the stream, other than, as I said, the few cases where I did a bit of work off stream, but not in preparation, just because it happened to be interesting at that point,
Right, right.
or because maybe something that Alyssa asked me to do, and it was like on a weekend, and yeah, I'll just do it tomorrow. Yeah, I mean that does happen, but
Mhm.
the vast majority of what I'm doing it on the stream.
Yep, yep. Well, I think it's important. Like, it sort of depends on what you're trying to achieve with the stream. Like, your stream seem to just be, as you said, you're just working. But if your goal is more to do like like with the XDC talk, it's a demonstration of what's
Yeah,
going on. Like, that's something that makes a lot more sense to go and prepare then.
yeah. So I did do like a presentation and Q&A stream where I had an actual slides, like the XCC talk a few months ago. Um, And so like that's different, of course. I mean, if you're going to be talking about how something already done works, that's pretty cool. And I
Hmm.
do want to do more of that, just so people can pick up on when we're at right now and how we got here and where things are going. That's also why I just wrote that Asahi Linux article that kind of covers the. I think we already saw it. That kind of covers the whole story
Hmm.
from April this year to now. So I do want to make more sort of produced content like that that is like explicitly produced to explain to people what's been going on or teach something because I think that's pretty cool and I should find more time for that. But what I meant is like like it's not like I am um, saying that I'm reverse engineering something and then I actually already figured it out before, right?
Yeah,
Like
yeah.
yeah.
Whoa, look at this
That would be a little bit weird.
magical thing I found. Oh, crazy.
Yeah. Yeah. No,
Yeah, no,
that's
that absolutely
yeah.
makes sense. Yeah. I've not read this article actually. I should actually go and do that. Well, actually, yeah, it does go over everything, doesn't it? So it goes from all the way from when Alyssa joined, from you starting on nothing, getting the triangles done. Huh. Okay.
Yeah, I glossed over Alyssa's like first year because she already documented all of that on her blog. So
Yep. Yep.
people should go read that on her blog if they want to get the 2021 story.
Mhm, mhm.
So I kind of started from where when I started working on stuff this year, and then including what Alyssa's been doing this year
Yep.
until now.
Mhm. Well, you got interested. We'll jump back into some of the development stuff. You got interested in Rust, and as I said earlier, I don't mean this in a mean way, but you are kind of a bit of a Rust shill at this point. You definitely like to proclaim the benefits of Rust. I like to mention Rust fairly often in my videos just because it tends to annoy people. There's a lot of people who get just very angry about Rust existing.
Ah,
Like, oh, just do it in C. C will just everything should be in C. Why Rust? What is the benefit of Rust for the work that you're doing?
I mean, I think the easiest answer I have for that is the example that um when I got the Linux driver rendering a cube after that
Mhm.
crazy YouTube crashing stream. The next week on the next stream, I did one stream working on stuff,
Mhm.
and then I had an idea like the next morning
Mhm.
to fix a problem that had nothing to do with Rust, and then I got a full GNOME desktop running. So I went from the cube to a full GNOME desktop in about 2 actual days of work. Um, because all the concurrency and like memory management and leaks and overflows and race conditions and all those things that are what make going from demo renders a cube to full desktop with a bunch of apps running at once
Mhm.
so difficult just didn't happen with Rust. And like this is a story that I just keep hearing from people. um it it's really it you can't really explain it until you try it
Mhm.
because it's just that feeling that you're like the code compiled and it works, right? You get C code to compile, and then you're gonna spend the next day debugging it.
Mhm.
Um, and with Rust, it's like it's gonna take longer to get it to compile because the compiler is gonna tell you how dumb you are all the time. But then once it compiles, it works.
Right.
I mean, of
Right.
course, there's bugs, right? I mean, we're always sort of like I mean, I'm enthusiastic about Rust
Mhm.
because I can really see the benefits. It doesn't mean it's going to magically make all your code perfect.
Mhm.
Obviously, there's logic bugs and things that are going to be wrong. And I mean, obviously, I'm still debugging things in my driver. Um, but it's mostly at this point, it's mostly about my understanding of the underlying hardware and firmware and the reverse engineering, and less so about like coding bugs because I messed up.
Mhm. Mhm.
Um, so the it's a very different feeling from writing C in terms of like how much time you spend before the compiler and then how much time you spend debugging. And the most important thing is that when you write code in C, the there's this like idea. There's this thing where like you kind of have to keep in your head all these rules about how everything works together
Mhm.
in the entire program. Because if any two parts of the program disagree about those rules, um, then that's an avenue for like something to go really wrong if that triggers,
Mhm.
right?
Mhm.
And because C doesn't make you enforce those rules, doesn't give you any tools to enforce those rules, and doesn't encode or even force you to think about those rules, then you don't, right? So you end up with this vague idea in your head of how it's supposed to work, but because it's a vague idea and the computer isn't helping you enforce any of it, you are going to make mistakes, right?
Mhm.
And so Rust kind of turns that on its head by saying, okay, you actually have to think about how this is going to work.
Mhm.
But because you think about it from module to module, right? You write these rules and it's built into the Rust syntax. It's just built into the type system and it's built into how Rust works.
Mhm.
Then the compiler guarantees that those rules are upheld by everything else. And so when you write Rust, you think about one box, and as long as that box is doing the right thing, which might include even unsafe code, which bypasses the Rust safety, but that's fine because like that unsafe code only has to work together with the safe code around it and in that one part of the program to make sure that it's not actually breaking. And then anything that uses that box doesn't have to care about any of that because the language guarantees that as long as just the one unsafe parts are, like doing the right thing, then nothing else is going to break in a way that's going to crash or, overflow a buffer or something like that. And so a lot of people say it's like, well, if you're writing Rust, if you add unsafe code, you're just throwing away everything that Rust does. Says no. Like my driver has, I think I'd add like maybe how many unsafe blocks? Like, let me just grep for unsafe real quick. Driver's GPU DRM Asahi. There's about 100 unsafe blocks in my driver, and it sounds like a lot, but like they're all doing one thing, right? In one part of a module. Some of them are duplicated, and it's just a pattern that is the same everywhere.
Yep.
And so each one of those only has to care about one particular part of the code, right? And it's I actually need to write comments. Not all of them have the comments yet, but I actually need to document all of those unsafe codes before upstreaming because that's a Rust for Linux rule, and it helps other people understand why that unsafe code is actually safe. But that's the idea, right? Is that you go there and you think, okay, I can mentally prove that this is safe because A, B, and C, and those A, B, and C are in this one file that I'm looking at right now, and I can prove that it's like that, and that is something that someone can review and then come to the same conclusion, right? And then you say, okay, this box is fine. Move on to the next box. And then all the interactions between those boxes, all those exponential ways that all of that can go wrong, don't happen anymore. And that's where you get the magic of Rust. That's why that driver went from cube to full desktop in a couple of days because that crazy web of things to go wrong when you have 6 apps using the GPU at once, there's nothing for it to go wrong there in Rust.
So what you're saying is that you just need to be a better programmer and C works.
That's what all the people say.
That is what all the people
write good
say.
C code. Like, I've yet to meet a good C programmer that can actually do what you can do with Rust.
No, I don't think there's anyone who's actually like a really maybe there is, but I think most people make the argument that you don't need Rust to do this. You just do it in C. I have a feeling a lot of those people don't have that kind of experience working in that sort of code where it is really, really important. These people may have experience with C, but may not fully understand the problem space that they're commenting about.
Yeah, the thing is, we're human, right? We're not perfect, and so we rely on tools to help us get our job done. C just doesn't give you those tools, right? So you can tell yourself, well, yes, you can do the same thing in Rust that you can do in C, because by definition you can. You can also do it in assembler. You can also just write the machine code by yourself, right? Like, why not use the tools that make your life easier, make you more productive, and make you make fewer mistakes, right? And so, of course, you can write perfect C code and you could even take a Rust program that already follows all these rules and convert it to C. And as long as you don't miss anything, it's going to be as reliable as the Rust program because the Rust compiler already forced you to design it in a way that solves these problems, right? So then it just becomes an issue of translating every single thing that the Rust compiler does behind your back to C, which is possible. But then you're still taking advantage of the Rust design, right? So
you've just re-implemented Rust.
Yeah, manually, right? You just turn yourself into a Rust compiler, and so it's because Rust forces you to have that design, right? It's very difficult to have the self-discipline to come up with a design that doesn't have any weird corner cases in C. You might think you can do a better job, and there's people who've come up with paradigms that, in theory, improve things, and you can do better in C++ with smart pointers and things like that. But nothing, it's like a proof checker. When the compiler is telling you it can prove that your code doesn't have any of these problems, that's not something that you as a human can do without spending an inordinate amount of time on it.
Yeah.
So just let Rust do it, right?
Yeah, there's no point just wasting your time. We improve tooling for a good reason. Like, there's no point just wasting your time just, you know, making things harder for yourself just for the sake of it. Like, there obviously are merits to doing things in C, but in the same vein, there are merits to the there are merits to the more, how would you say it, like, not complete, the the better checking that the Rust tooling offers you, if that makes sense.
Yeah, I think really at this point the only reasons to use C are because it's already a C code base, or
Mm.
because Rust doesn't support it on the target you want to support,
You use
or
C because you have C
yeah,
developers.
yeah, pretty much. And I mean, Rust doesn't run everywhere that C does, so it's
Yep.
obviously not going to replace C for everything right now. But like, there's relatively little reason to start a new project in C versus in Rust on a platform that has both.
Hmm.
If it's, I mean, if it's, of course, there's the argument that if it's something simple, you can just do it in C and you don't have to care. Sure, but like, um, that's just inertia, right? You can still do it in Rust just by learning Rust. Um, but there's, you know, Rust can do almost everything C can do. I ran into one. There's one thing. I have one complaint about Rust. There's one thing that Rust right now makes very annoying. Um, and I've talked with the Rust for Linux people about this, and so I'm using a workaround now. But basically, Rust's idea of creating objects in memory
Hmm.
always puts them on the stack, and then you can move them because it works by moving into some other memory location.
Hmm.
But there's no ergonomic way to create an object already at a memory location that you chose, like with a
Hmm.
custom unsafe allocator or something. Um, and so the problem is that in user space, that's fine. In the kernel, stacks are like 16K.
Right. Right.
Some objects for this GPU are 64K.
Okay, that's a problem.
Yeah. So that's a very specific to Rust for Linux problem, although it can make optimization a bit harder on user space too. The compiler can usually optimize these things, but optimization is not something you can rely on. So it it helps if you can tell the compiler to do this directly. There's no good way of doing this in Rust right now. I have a ridiculous, horrific macro that kind of works around it by piecewise constructing the object field by field directly in the target memory. And that's what I'm using, and it works. And that's fine. We work around language limitations. There,
Uh-huh.
we work around problems with the tools we have. C would have had its own giant set of problems if I tried to do what I'm trying to do in Rust here.
Hmm. Hmm.
So every language has its pros and cons. And I'm not talking about safety. I'm talking about just general like programming stuff. Like I would have had to do some horrible things in C to get this driver done in C, which Rust makes a lot easier. So it's not perfect. But I mean, there is a discussion with the wider Rust community about this. It's been an open issue for a long time. We'll figure something out eventually, because Rust is only getting better. But yeah, I mean, it's not a perfect language. Of course, there's things that are still, a bit annoying. But I spent like the first 2 or 3 days when I started writing the kernel Rust driver, chasing these sort of Rust pain points on Linux and discovering more of them.
Hmm.
Because I'm also kind of the first person to make a big driver in Rust for Linux, right? I mean, nobody had needed big structures in a Rust for Linux driver until now, because the drivers that people have written until now don't need that. Um, so that's to be expected because I'm kind of an early adopter here.
Hmm.
But once I got past that, right, and I got into like writing the actual driver itself and using all this tooling and these workarounds that I had built in the first couple of days, that was really like a joy. And it's not just the safety stuff. Like even just error handling in Rust is like one character. You put a question mark on, and it just like does the error return. And because it does memory cleanup for you, you don't have to worry about cleanup. So regular Linux C code is full of these patterns where like every function is like do something, do something, do something, do something, and after everything, it's like if it failed, go to error. If it failed, go to error. And then because you have to do cleanup, it's like if it failed, go to error, clean up this. If it failed, do the error, clean up that. And then at the end of the function, you have return something, and then error, clean up this, error, clean up that, and you have this like pile of, error cleanup, like manual error cleanup that you have to do.
And that right there is one of the obvious places you can make a mistake.
Yes, and like people find those all the time. Um, that just goes away in Rust.
Hmm.
And it also manages all the like when you get complicated functions, the possible go-to paths get insane. Nobody gets that right in C. Sorry. So with Rust, that was another thing that happened. That I, Zonotic was running out of memory, and it turned out it was just legitimately running out of memory. It wasn't a memory leak. It's just that Zonotic on Ultra, without texture compression, which we didn't have yet, does not fit in 8 GB of RAM. So that was just legitimately running out of memory. And, the app crashed and the kernel killer went crazy because the priorities were wrong and like it killed the whole desktop or something. The driver returned errors and the basic driver complained about out of memory errors. Nothing went wrong on the kernel side, right? Like the out of memory paths on the kernel driver just did the right thing. And normally, that's another thing. It's like the first time you test error paths, something is wrong, something doesn't get cleaned up, you end up with another, you just have to freeze something. No, all that just worked. So that's the other thing with Rust is the error handling together with the, implied cleanup of resources because it's all, does that for you, makes it so much easier than, the whole C thing where you have to return an error code from everything and convert it and forward the error codes and check for it. It's literally in Rust, this is put a question mark after the function and it does it for you. If you don't put a question mark, it complains that you didn't do that.
Oh.
So, yeah.
One of the things that I think some people people will use this as like a disadvantage of Rust, but also will forget at the same time. Rust is only like 0.1 came out in 2012. It's still a really young language, and it's not a young language that like nobody's using. Like there are engineers at Microsoft, there are engineers at Google, there are engineers at all of these massive companies that are using Rust to different extents, but this tooling is only going to get better and better and better. Like, C is how old at this point? I don't know. Very old. C language.
The first NC version was
72.
89, and then the actual like ancient C goes far back.
Yeah. But yeah, Rust is 10 years old. And as projects like Rust, like there haven't been these really big, ambitious Rust projects before what you're doing, before what Rust for Linux is doing. This tool needs to be tested on this large scale to work out where it has these inadequacies and what needs to be addressed to bring it to this state where it's, going to be properly usable for this. And it needs these people who are, I guess, who are trailblazing, who are trying to like find out where it's going to be inadequate, where it needs to be improved, and sort of what can really be done with it.
Yeah, and a lot of it is just specific to like specific environments, right? So what I found with the stack stuff on Rust for Linux, I know there's like whole OSs written in Rust now, and they probably either don't have to deal with this because they have dynamically growable stacks or whatever. It depends on the design of the OS. So you're always going to find new interesting issues when you start using a tool for the first time in a different environment.
Yep.
And the Rust project has made changes in response to Rust for Linux and what Linux needs from Rust. And Rust for Linux themselves, they've done a lot of work into how to use Rust in Linux and what the right way of modeling like Linux concepts is, how to handle Linux errors, how to make it convenient for the code, and like what the right balance is between it looks like regular user space Rust code and it looks like kernel C code. You need to pick exactly, sort of where that line lies, and there's an art to that. So that's something I experienced when I wrote because I had to write not just the driver, I had to write the general Rust support for graphics drivers for Rust for Linux. And so that was the first thing I had to do. And so, I haven't even got that reviewed yet, but, it took a couple of iterations to figure out a reasonable way of doing that. So there's a lot of work that goes into that. And yeah, of course you're going to run into things and we're still going to keep running into things. But that's the case with any tool, and it's the case with C. People run into weirdness with C all the time too, so that's not unique or anything. But I think Linus Torvalds merged it into Rust precisely because, like, it's good enough that people can actually use it, and it's only going to get better. And one thing that I noticed is that even though there's a lot of random media attention, the Rust for Linux community is actually tiny. There's a relatively small amount of people, even if you're actually doing stuff. And so it needs more attention from actual developers who might do stuff with this.
Yep.
But the intersection of Rust programmers and kernel programmers is very small right now because like everyone's doing C in the kernel and everyone's doing Rust in user space. So I think what Linus wants to do and also what I'm doing with this driver is sort of trying to get those two groups of people together more to get this out there and more people using it. And some of that is just having long discussions. Like we had a long talk on the Rust for Linux Zulip about how safety works in Rust drivers. And there was a lot of nuance because, like I mentioned about this box thing with safety, unsafe blocks inside and stuff, right? When you're writing a library in Rust, the box is the library or the module inside it usually. And so if you have multiple modules, you usually want every individual module to be safe by itself. Like you can't do anything unsafe from the outside.
Yep.
But with the driver, the required safety boundary is actually the user interface because the user from user space can't do anything evil. But because it's hardware, when you get to complicated hardware like my driver, I can make every individual box as safe as is possible for that box to be. But I can't make it 100% safe because at the end of the day, the whole driver is driving the hardware, and there are complexities to make it safe. I need to understand how the firmware works. The firmware is written in C, and it's not nice little boxes like that. And in the end, the whole driver has to work together properly. So there are some properties like, for example, when I submit a command to the GPU and there's a bunch of data structures in memory, those can only be freed when the command has completed. And that logic spans multiple modules, right? Because like the command completion comes in through one and then ends up in another and all that. So all that, obviously you could, like I could write code into the command completion receiver to say that you're completing a command before it really completed, and that would crash the GPU, of course, right? And like Rust can help me with that, but that's a very simple process for someone to understand who's looking at the driver, right? That's not a process where like that thing is going to magically say a command completed when it didn't, because we got the flag, and like you can look at every part of that chain and say this is right. And so that means that from if you think of safety as including the GPU in this case, but also it can include the CPU in more complicated cases with other hardware. It's not as nice as user space Rust because you can't say every individual block is memory safe, but you're still like the number of things that are related to safety that span multiple of those blocks is much smaller, and you can think about everything individually and then very easily convince yourself that it's safe and that the whole driver is safe overall. So that's a discussion we had to have with the Rust for Linux folks, because it's like, how do we define safety for a Rust driver? It's not like a user space app, and like I had to both teach some of the Rust folks how this whole hardware thing works and why it's not like user space. But yeah, like that's why we have these conversations, right? Because we need to all be on the same page as to how these things work. And at the end of the day, the thing that matters is that Rust is making this so much easier, right?
Yeah.
So there's nothing to be lost by saying, well, it's not as nice as user space Rust. It's still way nicer than kernel C, right?
One of the things that I've seen people who are very against Rust bring up. I don't know if I can find. It's one of the early from one of the early emails where Rust for Linux was going to be like when I think it was one of their first requests for comments where Linus was saying it was something about you can't just crash the I think it was when the code ran out of memory, it was just going to just instantly crash or something like that. Let's see if I can find the email. You probably know what I'm talking about. I can understand
that's a big thing about kernel Rust is that a lot of the regular Rust APIs are disabled for that reason.
Yeah. I wish I could find the email right now, but I can't find it. But you do. Okay, you do know the one I'm talking about, though. I was just trying to find it for everyone else.
I never remember the email, but I know the issue you're talking about. Yeah.
Yeah. And I can understand why there's you have these people who are really interested in Rust, and then this section of these developers who are very interested in keeping things, stable and making sure everything they know that everything works. And if these people are coming from more of a user space background, I can see why there'd be like a bit of a disconnect there initially, but that doesn't mean that it always has to be like that. You can share that knowledge and sort of bring these Rust developers in line with what the kernel needs for its requirements. But one of the things that I can understand as a concern from people who are maybe a bit wary about the introduction of Rust is whether Rust is going to be a language that's around for a long time, because it is still a really young language. Because you've got Rust coming into Mesa with Rustical, you've got the Rust for Linux project. There is obviously right now a lot of hype, a lot of interest around Rust, but C's been around for all this time. We know C is going to be here forever. Where do you sort of like? Do you see Rust being this thing that becomes that, like, maybe not completely replaces C, but becomes a language alongside C? Or do you see it sort of fading into the background like many languages of the past, like Fortran and COBOL? They still exist to some extent, but no one really cares about them unless they need to be touching them.
So the thing is, like, Rust is bringing in something very useful to the table, right?
Mhm.
So the reason people are using it is because it does something that no other language has really gotten right before.
Right.
And like, I don't want to dig on any languages, but just as a random example, like Go is sort of, supposed to be another modern C replacement thing,
Mhm,
but it
mhm.
doesn't have the guarantees that Rust does. So you can do lots of evil things in Go to crash your computer. Um, so Rust got a lot of these things right.
Yep.
Got a lot of the can actually be used in kernels and embedded systems and low-level systems programming right. And so people are using it, right? And
Mhm,
since it's an open source project, I don't think there's really a risk that it's going to just disappear,
mhm,
because that's only going to happen if people don't use it, right? So if people use it, it's going to be around because there's always going to be someone to help out with the compiler, even if the current team disappears or something,
mhm,
because there's enough people using it that it matters, right?
mhm.
Um, so I don't think there's really any risk that it's going to fade away unless something even better replaces it.
Right.
At which point it's like fair. Um, because I mean these open source projects are sort of maintained in a feedback loop, right? And especially something as big as Rust is not something that's just gonna go, like like undetected and like end up unmaintained and nobody notices or something like that. So I think it's we don't really have to worry too much about that.
Mhm, mhm. Well, that's sort of replacing another tooling kind of did happen for, like, not to Rust, but Rust doing that to something else with the what was it, the Clover implementation, the open source implementation Clover,
Right.
where no one cares about the C++ implementation anymore. Everyone's focused on Rustical. It's like, well, someone could come along and deal with this, but no one did for like 2 years. Now there's a new one. I guess this is what we're doing now. I guess it's Rust. Rust is the future. Who cares about
And
that old?
And the person who wrote the C++ one like showed up and tried to argue against the
I
Rust
did
version
see.
of the MR. And the thing is, like, this is just like pragmatic, right? Like everyone involved agreed that they didn't want to touch the C++ one,
Mhm,
and that they much rather use the new Rust one and like maintain it, and that it was a better idea. And like
mhm.
when it's just about what people think on the project, right? Like this is if nobody wants to touch the C++ code base and everyone is happier trying out a new programming language, maybe there's a good reason for that.
Mhm. I can't recall who said it on that GitLab, but someone, might have been Dave. Yeah, I think it was Dave who said even if this Rust implementation doesn't end up working out in the future, and the same thing happens that happened with Clover, everyone moves on to something else. It doesn't really matter. It's not wasted effort because now we know that it can be done with Rust. Now we have a better understanding of how to properly implement OpenCL, and we can do it better into the future, and hopefully keep something around that is going to be this long term implementation.
Yeah, that's also something that I talked about with Alyssa when I started working on this in Rust because it wasn't merged into Linux yet. There was no guarantee that it was going to be merged. But if it never is, and sort of the thinking at the time was like, well, even if Rust never makes it into Linux, doing this in Rust first and then rewriting it in C is probably going to end up being a much higher quality driver, as I explained before, the same kind of process, right? Than if I just did it in C from the get go.
Right.
So yeah, even that has merits.
Well, it sort of takes you back to the thing from before where it's the C implementation was going to be a harder thing to do, whereas if you do it with this, well, it's the reason why you started with Python, didn't start with doing it in like C or whatever. You start with the easier tooling, and then if you need to go to something that is a bit more complex, then you can do that later down the line. But it's not like that previous knowledge you had is just wasted, because you don't just throw away your, in this case, your reverse engineering knowledge of the driver. You still have that knowledge, so doing that next implementation is going to be easier.
Yeah, and it doesn't even have to be all in Rust, right? So Rusticle is a Rust layer, but it still uses all of the Mesa C nerd tooling. It binds it, and it integrates with the rest of Mesa. I'm sure a lot of work and sweat and tears went into that, because it's not that nice to make Rust and C work together. I mean, it's a lot nicer than C and Go at least, but it's
well, it also
still,
has to
you
hook
have to
in
think a
with
lot about those interfaces.
Sorry, I was going to say also has to hook in with like what's happening with the Intel drivers and Novo and Radeon SI drivers.
Yeah, exactly. So it all has to work together, right? So when I started the Rust driver for the GPU on Linux, I was actually using the MMU code from Panfrost modified. That didn't last too long because I realized I had to kind of redo it for other reasons. And at that point, it didn't make any sense to keep it around in C. But had that not been the case, that might have been in C for a long time. That's fine, right? I mean, it's still just one part of the driver. It's based on existing code that has been tested. No one's forcing you to do the whole thing in Rust. And there's still some random, parts of the kernel API that I use that are not properly wrapped in Rust, and that needs to happen eventually. But again, that's something that you can do incrementally, right? So it doesn't, none of this forces you to say, throw away all the C and do everything in Rust, right?
I think you had something to say on that. One thing I don't know how I skipped over this earlier, but we're gonna jump all the way back to the current drivers you have, and one other thing that wasn't directly related to the drivers, but it was the battery life. The 8-hour battery life that was estimated from the battery controller.
Yeah.
Was that so? That was just the estimation. You hadn't done a proper 8-hour benchmark to see if it was properly gonna do that, or?
Yeah, it was the estimate, but I mean, I think those estimates are accurate because they come from the battery controller and it's based on like power consumption over time and how much capacity the battery has. So it's not one of those random like based on battery voltage things or something like that, or based on like software. It's literally measuring the current. So I mean, I could do the test. I just haven't bothered because I don't think it's necessary. I don't think there's a reason not to trust that. I mean, maybe it's 7 hours instead of 8, but whatever. But it's not going to be like 2, right?
Do a development
it's not going to be 2 hours.
Yeah. Do a development stream where you just run it on batteries, see when it dies.
Maybe I should do it on Twitch because I already did a stream on Twitch where I was like collecting data from what was it? The power levels, and I just had like a for loop trying every possible input just to log the results to try to figure that out. And I think I left it running on Twitch for like 30 hours, something like that.
Jeez.
It's like watch Lina's computer reboot the M1 Ultra every 26 seconds for 30 hours.
It's not the worst stream I've seen on Twitter. There was someone who, ages back, I think they were installing, they were compiling Gen 2, I think it was on like a PS2 or something.
Oh man, that sounds
terrible. And they just had the compilation just sitting there. They weren't talking, no face cam, they just had the stream going.
You know what's funny is that sometimes when I have to do like a Mesa recompile or a kernel recompile, especially kernel recompiles, and I'll do that while I have a snack on my streams. And the kernel recompiles, like full rebuilds on my old Intel desktop, take forever. But lately I've been doing more Mesa recompiles, and those happen on the M1. And on the M1, they're fast enough that I usually can't finish a single snack before they end. And then there's the M1 Ultra, and that's just like, don't even bother. It's gonna be done before you take the wrapper off. The machines are very nice.
Mm-hmm. Well, yeah, I think there's a lot of people that have a hard time separating the hardware that Apple has made from the general tech practices Apple has. I think we can all agree that the way that Apple handles right to repair is pretty terrible. But we have to admit that what they've done with their new silicon is very impressive. Like, this hardware is kind of crazy.
It really is, and like the 8-hour battery life, a lot of that is just down to their power management, and that happens in hardware, or it's just built into the system.
Yep.
Because people say it's like Linux has no power management. Well, it has some power management, and the hardware does the rest of it. So that's why it works, right? And yeah, it's really impressive. And I think a lot of it comes down to both having silicon engineers that really care about the project, but also a smaller team that somehow ends up working together. Because I mean, there are some interesting horror stories of Intel and how it works internally. And it sort of feels like every big company kind of becomes more inefficient over time. I've also heard horror stories from Apple, sort of having people crunch like it's a startup, which also isn't good. But for us users, at least, the end result has been really nice. And the silicon is one part, and then the other part is just having the whole machine being made by one company means you don't have 37 OEMs fighting each other for how to make this all work together. And like I can understand how it happens with Apple, but it's very difficult to compete with that.
Yeah. I think one of the important things about this whole Asahi Linux project is even if it never gets to that like performance parity with the macOS system, it's going
to. It already runs faster than macOS some things, right?
Yeah,
Today,
sure.
Someone said a game ran better than macOS. Some compute workloads run better than macOS. Like Linux is a different OS from macOS, so some things it does better, and those of it run better.
But the point I was getting at here was there's going to be a point where Apple no longer is providing software support for these original M1 systems.
Yes.
And at that point, basically the system becomes e-waste. But when you have something like Asahi Linux, and hopefully by that time, a lot of the stuff that you're doing, a lot of the stuff the rest of the project is doing is being upstreamed, is out on other distros, and it's not like, hey, you have to go through this like weird extra step to get everything working. It's more like just grab a thing and you're good to go, basically. It gives this hardware another life, and it's like, I can't remember how long Apple generally does their hardware support cycle for, but by the time that they stop supporting it, it's still going to be really fast hardware, and it's still going to have a use case.
Yeah, and it's also going to be a very power efficient hardware, so still very nice for like travel or simpler use cases and stuff like that. And yeah, that's also very important, right? Is that Linux has a support cycle that is kind of insane, right? Like, I think they removed 386 support recently.
486. 386 was dropped.
486, okay. 486, yeah. Okay.
386 was dropped in 2012. Which, yeah, even so. We're
talking like 20 plus years, right? Nobody else does that. So that's a very good opportunity for the hardware to have a longer life. And like in my experience, it's not as useful for like, the typical, well-off tech person who's going to be having the latest shiny anyway.
Yeah.
But it's a lot more useful to avoid e-waste by just making it useful for either, for example, as a server, you have in the corner to replace a Raspberry Pi. It sounds ridiculous to say that today, using an M1 to replace a Raspberry Pi, but 10 years down the line, maybe, right? And then also, I've had friends who do things like take older secondhand computers and refurbish them a bit, put Linux on them, and take them to like less developed countries and
Mm.
run like coding workshops there and things like that. And that's really cool stuff, right? And you
Mm.
can really do that if you have an OS that supports the older hardware and runs well enough to make use of it.
Yep. So, what is the next big goal for what you're doing? Like, where do you go now?
So the next big goal is releasing it.
Okay,
Which
besides releasing it.
and then after that, so it's going to be working on the UAPS stuff to get it into a sort of should run Vulkan in theory with all the features.
Mm-hmm.
And that's going to be also working with Mesa to get these things tested and adapted. But also, Alyssa is doing a lot of Mesa work, and I've been getting more familiar with Mesa side. So I'm actually going to be doing more C code on that front because I can help out a little bit too. And um, and then yeah, I mean, it's just kind of a long road, right? But at
Sure.
this point, I don't think there are really any um, big major milestones like the release right now.
Mm-hmm.
Because from this point onward, it's a lot more incremental. So
Mm.
I think the next big milestone would be upstreaming the driver or starting to
Mm.
upstream the driver. Um, until then, it's going to be a lot of, chipping at things, individual things. Um, and there's probably going to be a, okay, we are like OpenGL3 compliant point and things like that. Alyssa probably disagrees with me there, and for her, the milestones are, OpenGL compliance versions. But like in the end, all of that is like incremental work, right? You
Yep.
chip at the number until you pass the tests. Um, and so it's the same with the UAPI. You chip at it until it finally gets to the point where you can upstream it, and then we'll have a party about that. But yeah, there isn't going to be any like planned, major thing after this. I think, other than that, it's just working on things,
Mm.
figuring out performance issues, improving the design of things, refactoring stuff. Like we got compressed texture support in, we got frame buffer compression support in. Now Alice is working on like multi-sample anti-aliasing. And there's gonna be, there was a bunch of performance stuff around caching buffers and batch tracking and a bunch of other Mesa things. And I'm not gonna explain what all those are now, but it's a lot of stuff, right? And
Mm-hmm.
she's been doing some crazy stuff recently, and all of that is going to improve the driver a lot.
Mm-hmm.
But there isn't like any one individual thing.
I didn't think you would have like one specific goal because you seemed like you jump around with the different things that you're working on. You're like, I'm gonna focus on this thing today, and well, that's done. Let's go to this next one and this next one.
Yeah,
There's clearly a lot of stuff that still needs to be done, and a lot of stuff to keep you entertained.
yeah, and like you can't predict what's going to take longer, because this is always an unknown with reverse engineering. So,
Mhm.
like on yesterday's stream, I was planning to work on Mesa and get some test cases for tiling. I ended up spending the whole day getting test cases for the kernel side, getting clustering working because that was broken and it was a lot more it was I don't want to say complicated, hard to figure out than I expected. Like
Mhm.
the output of that like 8 hours or something part of the stream was a single line of code that was like a line x to a multiple of 2, a line times y to a multiple of 4 divided like plus something divided by something. Like that one line of code took 8 hours to figure out to make it do the same thing macOS was doing, right? Because I could just see the input and the outputs.
Mhm.
And the alignment really threw me off. But the different X and Y alignments, like, why is X different from Y? What? I don't actually know how critical like getting that 100% perfect is, but I do know that when it was wrong, it was crashing with larger render sizes on the M1 Ultra. So it's all these little things, right?
Yep.
And you never know like how long the mystery is going to take. The power calculations took a couple of streams to figure out, and a lot of data gathering. So now that I know how they work, and the M2 was very similar to the M1 Ultra, I got the M2 done like the same day I wrapped up the M1 Ultra. So that's another good thing, right?
Mhm.
Which I guess we should also talk about how much easier it's been to get the M2 working once all the other stuff was already working. Because a lot of people said, oh, when the M2 comes out, you're gonna have to start from scratch.
Yeah, I think we
Um,
mentioned this the last time you were on. And correct me if I'm wrong, but what you'd said at the time, and you can expand upon this. Uh, Apple doesn't just throw away their silicon each generation. It's just it's a incremental improvement over what they were previously doing.
That seems to be a pattern that they've been having for a long time now.
Mm.
Um, on pretty much all fronts. And so, for example, I found an old like debug log from iOS on some like A10 or something device. Um, and sometimes you find interesting things on the internet. And it had like verbose GPU debugging, and so it had this giant dump of all the GPU states, and everything under matched what I know about the firmware on the M1. So
Mm.
clearly they've been doing this. I'm sure the actual like data was a little bit different and stuff. Like the concepts were the same. They haven't rewritten this. Um, so that's what we've been seeing with the new devices. And we knew M1 Pro, Max Ultra were going to be pretty similar to the M1 because it's the same generation, just a different variant of the GPU. It turned out that there was actually more work to get those working than to get the M2 working.
Mm-hmm.
And the reason was that those, it turns out that Apple implements like scaling GPUs in an interesting way. Um, we knew the M1 Ultra, people say the M1 Ultra has 2 GPUs because it has 2 M1 Max chips. It's actually 8 GPUs. So it turns out that the M1 Pro is 2 GPUs, the Max is 4 GPUs, and then the Ultra is just 8. So they've been doing this sort of scalability since the Pro,
Mm-hmm.
and that required new support in the kernel to make it work, and that was what I was fixing yesterday. It might still be broken, we'll see about that. But PM2 turned out to be the M1 with slightly different structures and a bunch of different power management data, which is exactly what I knew was going to happen for sure,
Mm-hmm.
and 0 backwards compatible breaking changes in user space.
Wow.
The same Mesa build ran on the M2 and the M1.
Well, that gives you hope for the M3 then.
Yeah. So I'll also take a bit of credit for like preparing the UAPI before we got to that point, so
Mhm.
that it could fetch the GPU generation from the kernel, and it like calculates the marketing name. So like it literally said M2 and the right version and everything with the 0 code changes. So I'm gonna take credit a little bit for that. Because it's nice when all that works. But yeah, there were no actual like logic changes needed.
Mhm.
And the kernel needed a bunch of not logic changes. It just needed some structures which are different, and they knew that was going to happen because it happens with different firmware versions too on the M1.
Yep.
So that was already supported. I just had to figure out the differences and put them in. Um, and the power management stuff, yeah, the power management stuff is just crazy. It's just like every time there's a new chip, there's like new numbers and new structures and new things where those numbers go, and we have no idea what most of those numbers are. At this point, my job is just to like um, organize those numbers in a way that looks vaguely reasonable and
Yep.
put them into a file. And mostly make it look like it's not a firmware blob, because like if you literally take like a memory dump, then you can get shouted at by people saying that this is some proprietary firmware blob.
Mhm.
So like my job is to like at least break the binary blob into a bunch of numbers that look pretty on the screen, so that like you can convince people that it's not firmware. And it's just a bunch of like power management curves or something, which is
Mhm.
not copyrightable data because it's hardware descriptions. So as long as I can do that and get it into a form that like looks like, okay, we don't know what these numbers are, but they're clearly something that's not code, then that's fine. And so I have to
Asahi
do that with
Lina,
every chip.
they're clearly something.
No, I mean it's like that. Like the M2 had a bunch of new curves and a bunch of the memory structures that we hadn't seen before,
Mhm,
and it's
mhm.
like, okay, -1, some incrementing numbers. The count is the number of power states the GPU has, and then padding with
Yep.
-1s. I have no idea what those numbers mean.
Yep. Yep.
Oh, but I need to give them to the firmware so I can do its job.
Mhm. Mhm.
So, like, what? Yeah, I mean, I just put them into a table and call it unknown 1, unknown 2, unknown 3, and what am I gonna do, right? But this is what happens with reverse engineering, especially low level like power management,
Mhm.
because it's literally magic. It's just like magic constants, and unless the person who wrote the code tells you, or you go reverse engineering the driver or the firmware to the point where you can understand it, there's no way to figure it out.
Mhm.
Like, how am I ever gonna find out what that curve does unless like I could spend the whole week changing it and trying to find what it does. It's possible it does nothing, and maybe it only triggers when the GPU goes over temperature or something. I don't know, right?
Yep.
So as far as all that power management stuff, what I always do is I clean it up. I try to calculate everything that seems to be related to something else to avoid duplicating data.
Mhm.
I put it into at least the some vague form of a structure that looks reasonable with the data in the right types and stuff, so it doesn't look like a hex blob.
Yep.
And then I implement it in the driver and send it to the GPU, and I take then a dump of the output and compare it with the same dump from macOS and just make sure it's the same
Yep.
or the
Yep.
same within running error. And as long as it's the same, I'm like, okay, this is good. And that's it.
Yep.
So only the parts that change, like from chip to chip, are things really have to work out. The parts that are just static, it's just like it's just data in a file in the
Yep.
driver.
Yep. Well, the last thing I wanted to ask you about is, let's say you get to the point where at least you're happy with it and you're ready to get things upstreamed. You haven't, like, sent it up yet. What is the process of actually getting something, merged mainline?
So it's not a very complicated process, but it's a little bit baroque to put it mildly.
Mm-hmm.
Um, so you basically just have to submit it to the kernel mailing list that is appropriate and send an email to the right people.
Mm-hmm.
Um, and in this case, it's going to be more involved because, of course, it's not just the driver, it's also the Rust abstractions for the DRM subsystem in Linux.
Yep.
And it's also, I depend on the Rust for Linux patches. So if there's stuff there that isn't upstream yet that I still depend on by the time I'm upstreaming, I need to block on that or help push that forward. Because what's in Rust and the kernel right now is, just like hello world level.
Yeah. Yeah.
Doesn't even support ARM64. I hear there's new patches queued for the next round. So, it's they're clearly not leaving it there. It's going to keep moving forward, but we'll see where we are when I get to that point. Um, so I pull in downstream Rust for Linux right now, and so it's going to be a long conversation, and I'll probably have to start with some of those abstractions and um, pointing people at my driver and how it uses them, so they can review that.
Mm-hmm.
And so in this case, this would go through the DRM subsystem maintainers and mailing lists, and and then you pretty much go from there, right? So there's going to be iteration, cleanup. Even before going through that, I am probably going to send it to the Rust for Linux folks to get some reviews from them first
Mm-hmm.
and figure all of that out. Because they also have to review it in terms of Rust. But the DRM people have to review it in terms of graphics. And so, yeah, it's going to be a pretty complicated thing
Mm-hmm.
for this driver for a bunch of reasons. But, the process is fairly spelled out and fairly, like intuitive if you know the people you're dealing with. And that's important that I've been talking with the Rest for Linux folks, the DRM folks, and all that. So like, it's not like I'm showing up out of nowhere with a giant patch. They know I'm doing this, and we all have been talking about how to do this. And I got advice from the DRM folks about how to design the UAPI. I got advice from the Rest for Linux folks on how to do some abstractions. I
Mm-hmm.
gave them some advice about how to think about some things because I learned stuff while writing the driver, right? So like, I'm already talking with people. This isn't some I'm alone on YouTube doing my own driver thing.
Mm-hmm.
So yeah, I mean, it's pretty much just getting the conversation started at that point.
I think the talking to the right people is certainly a good call. I've seen there have been a lot of cases I've seen in the past where someone shows up with, like, a 50,000 line patch set. They've not talked to anyone yet. It's not even set up. Like, I've seen some where it's like a 50,000 line patch, not a patch set. They submit it and they're just like, what is this? Why are you here?
Should we mention Power VR? uh,
Oh god. So
that's
it's
the whole story, right? With the Apple GPU being based on Power VR and to what extent it's similar and to what extent it isn't.
Mm-hmm, mm-hmm.
And Power VR started up streaming their open source graphics driver for some Power VR GPUs in about the middle of this year. So after we already got most of the work done, but we did learn a bunch of stuff from that driver. It also kind of scares me. And I do remember the Linux kernel upstreaming post at one point being a single patch for the whole driver. So yeah.
So basically, even once you have everything ready, it's going to be sort of a long process to get it all the pieces merged in that you need to make sure everything's going to be able to work.
Pretty much, yeah. And you want to make it easy for people to review.
Yeah.
I'm not actually sure how to do this with Rust, because I mean, you get this problem with any driver that is big and large. But I think Rust exacerbates the issue a bit more because you tend to have more interdependencies between modules as far as getting it to compile than with C because the whole
Yep.
type system kind of, spans everything. So I don't know how I would like. Obviously, I can't submit my current Git history. That has to be squashed and rewritten. And I don't know how I would break the driver into pieces that can be added and actually compiled
Hmm.
independently until the whole driver is complete. So my feeling is that I'm just going to say like one file per patch and make a nice long explanation of what that one file does.
Hmm.
And then like add the make file at the end and say, okay, now the whole driver builds. Because I don't think I can do any better for this one.
Hmm.
Um, and that just depends on the driver and sort of how complex it is. Sometimes you can build it up in steps or in logical parts of the functionality.
Hmm.
But I think in this case, it's pretty much going to be just say, okay, please review each file individually. It's already modular and split up in a way that is reasonable. And we're just going to add the files one per patch, and at least that way we can have email threads per module. And because the make file comes in at the end, nobody cares. This is going to compile when you get to that point,
Yep.
which is fine as long as you don't break the build. It's fine. So that's my idea right now. I don't know if anyone else will have any better ideas. I'm open to that. But yeah, in this case, I think that's pretty much the best I can do.
I'm sure if you submit it like that and someone has a better idea, you'll definitely hear about it.
I mean, I'm going to ask about this before submitting it. So
Sure, sure, sure. Yeah, that makes sense. Well, it seems like everything is sort of coming along pretty well. Um, and this has been, a pretty informative episode. I hope that everybody listening has sort of maybe learnt something about what's going on with the work that you're doing, with the work that other people involved in the project are doing. Um, and yeah, I think we'll sort of end it off there. If people want to get involved with the work that you're doing, or just generally the work that Asahi Linux is involved in, where would be the best place to go?
so the main community is on IRC on OFTC. So the GPU stuff specifically is an Asahi GPU, Asahi Dash GPU. But there's other channels for the other stuff. They are all listed on the Asahi Linux website, so you can find them there. And like I'm there, this is there. Ella's usually there, and a bunch of other people working on different things related to the GPU are there. Um, if you're interested in Rust for Linux specifically, you should probably ask to join their Zulip instance, which is currently invite only, but they will, give you invites for that if you ask them via email. Um, and then, of course, there's DRI Devil on OFTC, same network for the general Linux GPU stuff. So, if you want to get involved with what I'm working on specifically, then yeah, definitely join Asahi GPU and talk to us there. Um, like we're happy to get more developers and more people working on the code and fixing features or finding regressions. If you just want to try the driver and see if it works, please wait a little bit until release because we have had cases of people showing up and I was like, oh, I tried this, it doesn't work. It's like, well, yeah, we know, we're working on it.
Yeah.
um but so like yeah but if you're like gonna be developing it and hacking on Mesa or hacking on the kernel Rust side, by all means just join in and we'll get you started. And I do think release is coming pretty soon, so hopefully that's gonna make things a lot easier for everyone.
Mhm.
Because right now you have to compile like 3 different things and get them all together to get it to run it all. And there's like an XOR conf and until 2 days ago there was a kernel command line argument on the M2, and there's always the difference between something developers are working on and that works on their machine with their setup and a difference
Yep.
and something that everyone can run on their machine. So
Mhm, mhm,
we're getting there on that. But yeah, it's to the point where developers can definitely help out.
mhm.
So if you're interested, drop by.
As for yourself, where can people find you and what you're doing?
So as you asked that, do I get to plug VD Social here?
You can plug anything you want to plug.
So I'm on Twitter at Lina Asahi. But with all the recent chaos around Twitter, I thought that it would be nice to have an alternate place for VTubers to hang out and meet creators and other people involved with VTubers. So Luda and I started VT Social, which is a Mastodon instance for VTubers. And over the next few weeks, we're going to be working on the infrastructure to make it scale and all that. We got some new hardware already. Um, yeah, so we have that, and I am Lina at VD Social. Or if you want to go to the URL, vd.social/@Lina. And yes, I'm on there. I usually post to both places, but sometimes I post to Mastodon only, so you might get a bit more stuff there.
Mhm.
And there's my email. Actually, you can just go on my website, asahilina.net, and I have like all my socials and links there. So that'll get you everywhere. And yeah, I hang out on IRC and also on the No Pointer Live Discord, which you can also get an invite on my website. And so that's No Pointer Live is just a group of friends, VTubers. We do development from games to hardware. We have people across the entire spectrum, and it's just a group of friends. There's no agency behind it or anything.
Mhm.
But we have a Discord, so if you want to talk to us there, you can do that. I have a channel for me, and I think that's pretty much it. But yeah, if you go to asahilina.net, that has all the links to everywhere, so you can pick and choose.
I will chuck those in the description down below. If there's anything that you remembered you wanted to mention, just send it to me. I'll add it in there.
Cool, thank you so much.
As long as I don't forget, like, I forgot half Luna's links last time, but it's fine.
I mean, if you put the website link on, that has like all the other links in it, so then you're good.
Yeah, I'll definitely put the other website there in case I forget other stuff. Is that everything you wanted to mention?
I think so, yeah. Thank you so much for the interview. That was a lot of fun.
Well, as for me, you can go find my stuff over on my main channel, Brody Robertson. Do Linux videos 6-ish days a week, usually. I've got the gaming channel, which is in the process of being rebranded at some point. Brody Robertson Plays, right now playing through Devil May Cry 2, and also... Wait, what am I playing? Kingdom Hearts 3 days. Yeah, that one. I'm soon going to be doing a collab stream with Rogue Ren. We're going to be playing through Pokemon Sapphire and Ruby, doing a Soul Link, so come hang out for that one. It's going to be chaos. Neither of us can remember Gen 3 Pokemon at all, so it's also going to be a randomizer, so it's going to be a mess. As for this, if you're listening to the audio version, the video version is available over on YouTube at Tech Over Tea. If you're watching the video version, the audio version you can find on any podcast platform, Tech Over Tea, iTunes, there's an RSS feed, chuck it in your favorite app. I like to use AntennaPod. It's a great app. It's open source, and yeah, it's pretty good. Yeah, I'll give you the last word, Lina. What do you want to say?
I need to get into more game collabs and stuff like that. It sounds like so much fun.
I know Luna's trying to get you to play FF14.
I know, and like it's just an environment thing. Like I don't have a good setup for that right now. And I just need to figure out how to do that. But we do play. I do have Mario Kart. We played that recently, and that was a lot of fun. So I need to do more of that and more collabs and get more people involved. And then I can sneak them into getting interested into drivers and Rust.
Well, yeah, then I guess that's going to be everything. So I'll catch you guys later.
Yeah, thank you so much for having me.
No worries, you're always welcome.